Hello everyone. So in this video we are going to apply the concept of net present value and present value that we saw in the previous video, and we are going to evaluate a very common type of security, which is what we call an annuity. So in very simple terms, an annuity is a security that will give to the owner a constant cash flow C every year for n years. Okay, a common example of annuity is a basic loan. So if you if you lend money to somebody, you might want to have a constant repayments. If the repayments are constant, you are in fact possessing an annuity. You are the owner of an annuity. So how can we calculate the present value of an annuity? We basically apply the formula for the present value. So if we apply the formula for the present value here, not connected. Just a second. Okay, there you go. So if we apply the formula that we got for the present value, we can write the present value of the annuity as C over 1 plus R, where R is the discount rate, plus C, which is the second payment. We divide that by 1 plus R squared, and we have n terms, C over 1 plus R to the power n. Okay, so this is going to represent the last payment. Now, notice that here what we have is a geometric progression. We are summing the first n terms of a geometric progression. And in this geometric progression, we have that the first term, which I'm going to call A, is equal to C over 1 plus R. So this is the first term of the geometric progression. And X, which is basically the growth rate of the terms in this geometric progression, is going to be 1 over 1 plus R. As you can see, each term in this progression is equal to the previous term multiplied by this number X here. Okay, and we know that the sum of the terms in this geometric progression will be given by A times 1 minus x to the power n over 1 minus x. Okay, so here A is the first term of the geometric progression, and x is the growth rate of the geometric progression. You can find this formula in any elementary math book, or you can just go to the Wikipedia page. You'll be able to find that there. Now we can replace the A and the X that we got in this formula here. So if we replace, we're going to conclude the formula. We're going to conclude that the present value is going to be equal to C over 1 plus R. Okay? And we're going to multiply by 1 minus X, which is 1 over 1 plus R to the power n over 1 minus 1 over 1 plus R. Okay. Now we can rearrange the terms to simplify this equation a little bit. So this is going to be equal to C over 1 plus R multiplied by. So the numerator here I'm going to keep as it is. I'm not going to change it. So 1 minus 1 over 1 plus r to the power n. And I'm going to rearrange the denominator a little bit. So we get 1 plus r over, in the denominator of the denominator we have 1 plus r, and then here we get 1 plus r minus 1. Yes. Okay. So this one is going to cancel with this minus 1. And this 1 plus r is going to cancel with this 1 plus r. So this is going to simplify to the following. The present value of this annuity is going to be C over r multiplied by 1 minus 1 over 1 plus r to the power n. Okay? And this is the formula for the present value of any annuity. In other terms, every time you have a security paying a constant cash flow of C for n periods, where the first payment is 1 period from now, this is the formula that you have to apply. Okay? And the natural calculation that we could do right now is the calculation of the present value of what we call a perpetuity. So the perpetuity is very similar to the annuity, but instead of paying a constant cash flow for n periods, the perpetuity is going to pay the constant cash flow C forever. Okay. Now, how can we calculate this present value? So, first, let's just write down the formula of the annuity. So, an annuity as a function of n, where n is the number of periods, is going to be C over r multiplied by 1 minus 1 plus r to the power n. Okay. Now you can think that the perpetuity is an annuity where the n gets very large. Okay. You're basically receiving this cash flow forever. This is similar to receiving a annuity. This is similar to receiving an annuity that is gonna give you this cash flow for a very, very long time. So if we make, n very large, let's say infinite, what's going to happen with this formula? So the first term, C over r, is unchanged. The only thing that depends on n in this equation here is this term, 1 divided by 1 plus r over n. So 1 over 1 plus r is smaller than 1. Is positive and is smaller than 1. And every time you have a number between 0 and 1, and you calculate the power of this number by a large number, this power goes to 0. Okay? So this number here is going to approach 0 when n gets very large, which implies that the term in brackets approaches 1. So this implies that the present value of the perpetuity is simply C over R. So it's a very simple calculation. We only have to divide the constant cash flow by the discount rate. Okay? And this equation is going to give us a very simple intuition. The smaller the interest rate is, the smaller the discount rate is, the larger the present value of the perpetuity is going to be. Okay? In the limit case, where the discount rate approaches 0, the present value of the perpetuity approaches infinite.